Hey everyone, and welcome back to the channel. Today we're diving into the fundamental language of chemistry, the chemical formula. Have you ever looked at something like a CHO or 3CO and wondered what all those little and big numbers actually mean? Well, you're in the right place. By the end of this video, you'll be able to read chemical formulas like a pro. It's way easier than it looks, I promise. So grab your thinking caps and let's get started. First up, let's talk about the letters. In any chemical formula, the letters are the chemical symbols for the elements. You'll find these on the periodic table. For example, H stands for hydrogen, O for oxygen, and C for carbon. These symbols are like the alphabet of chemistry, telling us which ingredients are in our chemical recipe. So when we see HO, we know we're dealing with hydrogen and oxygen. Simple enough, right? Now let's get to the main event. Those little numbers written slightly below the line. These are called subscripts. A subscript tells you how many atoms of the element immediately to its left are present in a single molecule or formula unit. Think of it as a quantity tag for that specific element. In our familiar water molecule, HO, that little 2 is a subscript. It's telling us there are 2 atoms of hydrogen. What about the oxygen? You might notice there's no number next to the O in chemistry. If there's no subscript, it's an invisible one. So HO means one molecule of water contains 2 hydrogen atoms and 1 oxygen atom. Let's try another one. How about glucose, the sugar that gives us energy? Its formula is CHO. Let's break it down. The C is carbon, and the subscript 6 tells us there are 6 carbon atoms. The H is hydrogen, and its subscript 12 means there are 12 hydrogen atoms. And finally, the O is oxygen, with a subscript of 6 meaning 6 oxygen atoms. All of these atoms are bonded together to form one single molecule of glucose. So, subscripts are all about what's inside one unit of a substance. They define the very identity of the molecule. If we change the subscripts, we'd have a completely different substance. Okay, so we've mastered the small numbers. What about the big numbers that sometimes appear at the very beginning of a chemical formula? These are called coefficients. A coefficient tells you the number of separate molecules or formula units you have. It's like saying how many batches of your recipe you're making. While a subscript tells you the number of atoms within a molecule, a coefficient tells you the number of entire molecules. Let's go back to our water example. If we see just HO, it means we have one molecule of water. But what if we see 2HO? That big 2 at the front is the coefficient. It means we have 2 separate molecules of water. To find the total number of atoms, you multiply the coefficient by the subscripts for each element. So in 2HO, we have 2 times 2, which equals 4 hydrogen atoms in total. For oxygen, we have 2 times the invisible 1, which gives us 2 oxygen atoms in total. The coefficient scales everything up. Let's make it a bit more complex. Imagine you see the formula 3NH. This represents ammonia. The 3 at the front is our coefficient. The formula NH tells us one molecule of ammonia has 1 nitrogen atom. Remember the invisible 1 and 3 hydrogen atoms. So if we have 3 molecules of ammonia, how many atoms of each do we have in total? We multiply. For nitrogen, it's 3 the coefficient times 1 the subscript, which gives us 3 nitrogen atoms. For hydrogen, it's 3 the coefficient times 3 the subscript, giving us 9 hydrogen atoms in total. See, the coefficient applies to every element in the formula that follows it. Now for a tricky part, parentheses. Sometimes you'll see a formula like CO. This is calcium hydroxide. When you see parentheses, the subscript outside the parentheses applies to everything inside them. It's like the distributive property in math. In this case, the subscript 2 applies to both the O oxygen and the H hydrogen inside the parentheses. The Cu calcium is outside, so it's not affected by that too. So, in one formula unit of KO, we have 1 calcium atom, 2 oxygen atoms because it's O times 2, and 2 hydrogen atoms H times 2. Let's combine everything we've learned with one final big example. What if you encounter for also? Whoa, that looks intimidating, but it's not. We can decode this step by step. First, identify the coefficient. That's the big 4 at the start. This means we have 4 separate formula units of this entire compound, which is aluminum sulfate. Now let's look at what's inside one unit. Also, we have aluminum Al, and its subscript is 2, so there are 2 aluminum atoms. Then we have the parentheses. Inside, we have SO, which is 1 sulfur atom and 4 oxygen atoms. The subscript 3 outside the parentheses multiplies everything inside. So for sulfur, we have 1 times 3, which equals 3 sulfur atoms. For oxygen, we have 4 times 3, which equals 12 oxygen atoms. That's all for one formula unit. But remember our coefficient of 4. We need to multiply everything by 4 to get the grand total. For aluminum, it's 4 times 2, giving us 8 aluminum atoms. For sulfur, it's 4 times 3, giving us 12 sulfur atoms. And for oxygen, it's 4 times 12, giving us a whopping 48 oxygen atoms in total. It's just a bit of simple multiplication. Breaking it down makes even the most complex formulas manageable. So let's do a quick recap. The letters are element symbols. Subscripts, the small, low numbers, tell you how many atoms of an element are inside a single molecule. If there's no subscript, it's an invisible one. Parentheses group atoms together, and the subscript outside the parentheses multiplies everything inside. And finally, coefficients, the big numbers out front, tell you how many total molecules you have. They multiply the entire molecule. Subscripts define the molecule. Coefficients count the molecules. Understanding this difference is absolutely key to understanding chemical reactions and the language of chemistry. And that's it. You now know the difference between coefficients and subscripts and how to read even complicated chemical formulas. It's all about taking it one step at a time. Practice makes perfect, so try looking up some of your favorite compounds and see if you can count the atoms. Thank you so much for watching today. If this video helped you, please give it a thumbs up and don't forget to subscribe and hit that notification bell so you don't miss our next chemistry adventure. If you have any questions, drop them in the comments below. See you in the next video.